determine the infinite limit, and the limit we're looking at is the limit as x approaches 3 from the right of x plus 2 over x minus 3. This is very similar to the last problem, except we're approaching from the right instead of the left, so we need to pick different x values here. To approach 3 from the right, we can look at 3.5, and then 3.1, and then 3.01, 3.001, 3.0001, etc. And so for 3.5, that's going to be 3.5 plus 2 over 3.5 minus 3. Let's do this one by hand, and then we can do the rest with a calculator. 3.5 plus 2 is going to be 5.5 divided by 0.5. Remember, dividing by a half is the same as multiplying by 2. 5.5 times 2 is 11. So we end up with 11 for our y value. Then from there, we can plug in 3.1 to our calculators. And all you've got to do is enter this in, but instead of 3.5s, you've got 3.1s. And when you do that, you get 51. And then you continue, and if you plug in 3.01, then you end up with 501. And if you go back in and add in an extra 0 in there for 3.001, you get 5,001. And the next one's going to be 50,001. And we can see that as we get closer and closer to 3 from the right, the function values are getting arbitrarily larger. And so that means that this limit is going to be positive infinity, because the y values are getting larger and larger and larger arbitrarily so. If we were to add in more zeros here, this would go from 50,001 to 500,001 and 5,000,001, etc., etc. And we can see that it is going towards positive infinity.